Hello friends, myself Dr. Nandakumar Rao from College of Engineering Ambazoge is going to deal with numerical methods in mechanical engineering. This is our 6th lecture. So in previous lecture we have seen the numericals to find a root of equation using bisection method. Now today also we are going to discuss few more numericals to find a roots of equation using bisection method. Let us see one more numerical. Now this is a numerical where algebraic equation is given. So find the root of algebraic function f of x such that the true error is below 0.5% using bisection method. So here true error has to fall below this 0.5% and true value is also given. True value of x is given as 0.453201562 is the true value of its root. Now he is asking us to find out the true the approximate root of this equation using bisection method. So first of all we have to find the lower approximation XL and XU. We have to assume XL and XU in such a way that if we substitute XL, it may lead to positive or negative value. So function may lead to positive or negative value. If we substitute XL in this equation, if it yields positive, then we have to take another value XU in such a way that the function value will be negative. For example, if we substitute XL is equal to 0 in this equation, so f of 0 works out to be 0 plus of 0 minus 1, so that is minus 1, which is negative. Now let us assume that in place of XU we substitute 1. So f of 1 if we substitute, so function value is 1 plus of 2 into 1 minus 1 plus 1 minus 1 gets cancelled. This will be 2 and this answer is positive. So earlier it was negative and now it is positive. So here when we substitute lower limit, it is going to be negative. When we substitute upper limit, approximation, then function yields to positive value. So it may be if we substitute lower approximation, it may yield to positive, and when we substitute upper approximation, then it may yield to negative. But these two should have opposite sign. This is the first condition for this bisection method. So you have to first, it is compulsory for the students to find out XL and XU. So XL may be any value which yields the function either positive or negative. If XL yields negative, XU must yield positive, or else if XL, by substituting XL in approximation in this function, if it yields positive, then it has to yield negative value if we substitute XU in this function. Now let us start with this. So first of all we have assumed XL as 0, then function value was minus 1, negative, f of XL was negative, and we substituted XU as 1 and function value was positive, that is plus 2. So it was plus 2. So this is XL is 0, XU is 1, and once it is negative and once it is positive. So this is negative and this is positive. Now to find out a revised approximation, we have to take average of this 1 and 0. Average of 1 and 0, that is 0 plus 1 divided by 2, it yields to 0.5. So now fresh or revised approximation is 0.5. So substituting 0.5 in this equation we get So f of x is equal to x to the power of 3 plus 2x plus minus 1 is the function. Now substituting 0.5 here, 0.5 to the power of 3 plus 2 into 0.5 minus 1, this yields as 0.125. 0.125, this is positive. Now we go here again in the table, this is 0.125, so this is positive. Now this function value, if it is positive, it replaces positive function, means this comes here. So here this 0.5 we write here, fresh approximation is 0.5 and the function value is 0.125. So why we are going to take it here? Because this is positive, old positive is replaced by new positive value, and this 0 we carry forward. 0 minus 1 is the function value, that is negative, and this is positive. Once again we find approximation by taking 0.5, average of 0.5 and 0. So 0 plus of 0.5 divided by 2, so the revised approximation will be 0.25. So this revised approximation we have to substitute in what you call the function. So these errors we find out afterwards. Okay, so here f of x is equal to 0.25. So this function revised approximation is 0.25. So 0.25 to the power of 3 plus 2 into 0.25 minus 1. So this yields as minus 0.4843 minus 0.4843. So this is negative. 0.48 minus 0.4843, this is negative. Now this negative value is going to replace earlier negative, so negative function replaces old negative function, that is the approximation 0.25 we take here, 0.25, and here we write minus 0.4843, this is negative. So new negative function value replaces old negative function value, and positive function value is taken as it is, that is 0.125, this is positive. Now again we take average of these two, 0.5 and 0.25, 0.25 plus 0.5 divided by 2, this works out as 0.375, and we substitute this into the function 0.375. So f of x 0.375 to the power of 3 plus of 2 into 0.375 minus 1. So this function value at 0.375 is minus 0.197, minus 0.197. So here this is minus 0.197, so this is negative. So for time being we stop here and we try to find out approximate error. So here at present, so this is a new approximation and we do not have old approximation, therefore approximate error is not calculated, but true error can be obtained because we know true value. So true value is 0.45320125. So true error for first iteration, this is approximate value, and true value is also known. So now we find out approximate error at first iteration is not calculated. So true error we are going to find out. True error is equal to approximate value and true value. Approximate value in first iteration is 0.5, and true value we know 0.5 minus a 0.453201562. So this is approximate value, difference of true value and approximate value divided by true value, that is 0.453201562 into 100. So now we get error as just a minute, right? Okay, this is correct. So here this error will be 10.326%, 10.326%. So here we write this error as 10.32. Okay, so then again this error we have to find out, approximate error. Now previous approximation is 0.5 and new approximation is 0.25. So to find out approximate error for second iteration, so old approximation is 0.5, new approximation is 0.25. 0.5 minus 0.25 divided by new approximation, that is 0.25 into 100. This gives us 1% here. Error as 1%. So here we can write error as 1% in this case. Then true error we can find out. So approximate value is 0.25. Approximate value is 0.25. Just remember this. So true value we know. True error is equal to 0.25 is approximate value. True value is 0.453201562 divided by, again, true value is 0.4532011562 into 100, and this gives us true error as 44.83%. So here it shows error has increased. No problem. This is self-healing method, that is 44.83%. Now again here we want to find out approximate error. So previous approximation is 0.25 and new approximation is 0.375. So approximate error is equal to 0.375 minus 0.25. Previous approximation is 0.25, new approximation is 0.375. Difference of this has to be taken. Whichever is smaller has to be subtracted from larger value, divided by, again, new approximation or revised approximation, that is 0.375. So divided by 0.375 into 100. So this works out as 33%. Now you can find this approximate error has increased 33%. Now again, to find out true error, so approximate value is 0.375 and true value we know. So true error is equal to, true value is 0.4532011562 minus approximate value or approximation is 0.375. 0.375, whichever is larger, from that smaller value has to be subtracted, divided by true value, that is 0.4532011562 into 100, and this error is, earlier it was 33, this will be 17.2%. 17.25. So 17.25. 17.25. So now this is this error is 17%. What is asked here in this problem? The true error has to be below 0.5%. So we have to continue with the iteration. So now again this is negative. Negative replaces old negative. New negative replaces old negative approximation. That is nothing but 0.375, because this is negative, old negative. This is new negative. That is minus 0.197, and this is 0.5. So this is again 0.125, which is positive. This is negative. Average of this 0.375 plus of 0.5 divided by 2. New approximation we get as 0.5, 0.375 and 0.5. Average will be 0.4375, and by substituting this 0.4375, f of x is equal to 0.4375 to the power of 3 plus of 2 into 0.4375 minus 1. So f of x 0.4375, f of x is minus negative 0.04125. So here we substitute this as minus 0.04 minus 0.04125. This is negative, no doubt, only just we need its sign. So this is the function value which is negative. Now this negative replaces old negative. This is a revised negative replaces old negative. So let's calculate approximate error. So first we erase this. Okay. So now we want to find out here. So approximate error. So previous approximation is 0.375. New approximation is 0.4375. So approximate error is equal to 0.4375 is new approximation, and old approximation is 0.375 minus 0.375 divided by 0.4375 into 100. This gives us 0.4375, 0.375. This is 14%, 14.28%. 14.28% is the error, approximate error, 14.28%. Now we want to find out true error. So this is approximate value 0.4375. So 0.45. True error we want to find out. True value 0.45321562 minus of revised approximation is 43. 0.4375 divided by true value is 0.453201.562 into 100. So this, if we calculate, we get this as 3.46%. So true error is 3.46%. 4.36%. Now this negative is a revised negative value, replaces old revised value, that is minus 0.041, and this approximation is 0.4375. So this positive is going to continue 0.5 and 0.125, this is positive. Now again average of this 0.4375 plus of 0.5 divided by 2. So this we get as 0.5. This gives us 0.46875. And if we substitute in the function 0.4685, so function f of x is equal to x to the power of 3 plus 2x minus 1. So this is 0.46875, 0.46875 to the power of 3 plus of 2 into 0.46875 minus 1. So this function is as plus 0.040. So this is positive. So this is positive value, 0.040. Now approximate error we can find out. New approximation is 46875, old approximation is 0.4375. So approximate error is 0.46875, 0.46875 minus old approximation is 0.4375 divided by revised approximation is 0.46875 into 100, and this gives us 6%, 6.66% as the approximate error. So here we get 6.66% as approximate error. Now true error we can find out. True error is equal to true value we know, that is 0.45321562. So 6.46875, whichever is higher that we take first, minus 0.453201562 whole divided by true value is 0.453201562 into 100, which is equal to true error at this case is 3.43%. 3.43%. So true error is 3.43%. Now this is what positive value. Positive replaces positive, so we take here 0.040. So this positive is going to replace here. This positive value, which is positive, is going to replace this old positive, and this approximation now here we take as 0.46875, and this is carry forwarded as it is 0.4375 minus, so this is negative, minus 0.041, which is negative. So positive is replaced, old positive is replaced by new positive. Now average of these we take bisection method. So here 0.4375 plus of 0.46875 divided by 2. This gives us 0.453125. So if we substitute this in the function, so function f of x is equal to x to the power of 3 plus 2x minus 1. So x value which we obtained is 0.453125 to the power of 3 plus of 2 into 0.453125 minus 1. So if we simplify this, it gives us minus 0.0007. So this function is negative now. So this so many zeros indicate that we are reaching to the answer. So now function is minus 0.0007. So this is minus 0.0007. So approximate error if we want to find out. So this is previous approximation, this is revised approximation. So we find out this error, approximate error here. So this is lower, this is higher, 46875 minus 0.453125. So approximate error is, previous approximation is 0.46875 minus new approximation is 0.453125 divided by new approximation, that is 0.453125 into 100, and this gives us approximate error as 3.44%. So we write here 3.44%, and then we try to find out true error. True error is equal to, true value is given to us, that is 0.4532, 0.45320, 1562 minus the revised approximation is 0.453125 divided by 0.45320, 1562 into 100, and this, if we find out, this is going to be 0.0168%. Now we can see here the true error is less than 0.5%. So this error, true error is less than 0.5%. So we can stop here, and this error is 0.0168%. So 0.0168%. So true answer or final answer which we obtained when the true error is 0.0168% is nothing but 0.453125. So the root of equation, we can write here the root of function f of x is equal to 0.453125, and approximate error which we have calculated is 3.44%, but the true error is 0.0168%. So which is the condition in problem that the true error should be below 0.5%, which is less than 0.5%. So this is how we have simplified this numerical. Now we'll move to the next numerical. This is another numerical where the function is transcendental function. And one more thing which is given is the root of transcendental function falls in between 0 and 1. So xl and xu are already given, and the true value of function xt, x true, is also given here. xt is 0.56738281. So true value is given. Now you need not to find out xl and xu. So already xl is given as 0, xu is given as 1. So he is going to say, if we substitute 0 in this function, f of 0, we get this as -1, which is negative. And if we substitute 1, then function value yields to be 1.71. So this kind of functions are known as transcendental functions. So actually it is given as x e to the power of x is equal to 1. So this is converted into the function as f of x is equal to x e to the power of x minus 1. Now let us start with this. So here in detail I may not be calculating the function values as well as errors. So only I will explain for first iteration or second iteration, and for rest of the things I will be writing the direct values. So now xl is 0, where function value is -1. Just now we calculated. xu is 1, which we have assumed or which is given in the problem, and function value is 1.71. So this is negative, this is positive. So now average of this 0 and 1, 0 plus 1 divided by 2 gives us 0.5. Now if we substitute function f of x as 0.5, so function f of x is given as x e to the power of x minus 1. So f of 0.5, if we want to find out, this is 0.5 e to the power of 0.5 minus 1. So this gives us minus 0.17. So here this is minus 0.17. Approximate error cannot be calculated, but true error can be obtained. So true error is, so true value is given 0.56738281 minus of new approximation is 0.5 minus 0.5 divided by true value is 0.56738281 into 100. So this first error is 11.87%. So 11.87%. Now this is negative. Negative replaces negative. So this is minus 0.17. This is negative. Old negative is replaced by new negative. So here this is 0.5. So positive is taken as it is 1.71, which is positive. Old negative is replaced by new negative, and average of 1 and 0.5 will be 0.75. So 1.5 divided by 2 is 0.75. So now substituting 0.75 in this function f of x is equal to x e to the power of x minus 1. So we get this as 0.58. This is positive. Now we want to find out approximate error. So previous value and previous approximation minus new approximation. So approximate error, previous approximation is 0.5, new approximation is 0.75. 0.75 minus of 0.5 divided by 0.75 into 100. So this gives us approximate error as 33.3%. 33.3%. And again, true error we have to find out. So true error is equal to, so true value we know, and approximate value, our new approximation is 0.75, so we take 0.75 first. 0.75 minus true value is 0.56, or true answer or true root of this function is 0.56738281. So this true value is given in problem itself, so this we have not assumed. 0.56738281 into 100. So this approximate error, this was 33 here, it will be 32.18%. So here true error is 32.18%. So now this is positive, positive replaces positive, so here 0.58, so this is positive, positive is replacing positive, so 0.75 here. Now negative 0.5 and minus 0.17, so negative is going to continue. Then again we take average of 0.75 and 0.5, 0.75 and 0.5 and 0.75, average will be 0.625. So average of this 0.75 and 0.5 gives us 0.625, and function value will be, if we substitute 0.625 in this equation, x e to the power of x minus 1, then we get this as 0.1676, which is positive. Now approximate error, so this is previous approximation, revised approximation, 0.75 minus of 0.625 divided by 0.625, so approximate error falls to be 20.0%. Then true error we want to find out, so true value is given to us, so a revised approximation is 0.625, so 0.625 minus of 0.56738281 divided by 0.56738281, so this is only, this is replaced by 0.625, and then we get true error again in this case as 10.15%. So this positive again replaces old positive, so 0.1676, and this is 0.625. Negative is going to be continued, 0.5 as it is, and minus 0.17, this is negative. So now average of this 0.5 plus 0.625 divided by 2 gives us 0.5, and 0.625 is 0.5625. So substituting this 0.5625 in this function x into e to the power of x minus 1, we get this as minus 0.012, minus 0.012, which is negative. Now this is going to be negative. So now we want to find out approximate error. So to find out approximate error, so previous approximation minus revised approximation, 0.625 approximate error is equal to 0.625 minus of the revised approximation is 0.5625. 0.5625 divided by 0.5625 into 100. So this approximate error is going to be 0.5625. Okay. So this error is going to be 11.11%. So 11.11% we can write here, 11.11%. Then true error can be obtained. Approximate error is known. True error is again 0.567382 this is true value, minus of revised approximation is 0.5625 divided by true value is 0.567382812 into 100. So this true error is 0.86%. 0.86%. Still it is greater than 0.5. So this is negative. Negative replaces old negative. So minus 0.012 and 0.5625. So this positive is going to be continue 0.625, and this is positive. Positive is going to continue 0.1676. Again this is positive. The average of these two 0.5625 plus of 0.625 divided by 2, which gives us 0.5625. 0.625 average is, just I will write directly average. Average will be 0.59375. Average of these two 0.625 and 0.5625 is this one. And if we substitute this value in this function x e to the power of x minus 1, so this gives us 0.075, which is positive. Again we find out approximate error. So 0.59375 minus 0.5625, approximate error is equal to old approximation and new approximation. New approximation is higher, so 0.59375. 0.59375 minus of old approximation is 0.5625. 0.5625 divided by 0.59375 into 100. If we multiply it by 100, then approximate error for this 0.59 and 0.56 is going to be 5.26%. So 5.26%. Now true error we have to find out. 0.59375 is new approximation. So true error true error is equal to, so true value is 56. Therefore new approximation we take 0.59375 minus of true value is 0.567382812 divided by true value is again 0.567382812 into 100. So this gives us true error as, if we calculate this, will be 4.64%. So 4.64%. 4.64%. Now this is positive. Positive is going to replace old positive. So this is 0.59375. So function value positive. So this is positive. Old positive is replaced by new positive. So this is 0.075 positive value, and negative value is going to continue 0.5625. This is negative 0.012 negative. This is negative. Average of these two 0.5625 and 0.59735 is going to be 0.578125. So this revised approximation, if we substitute in this equation our function x e to the power of x minus 1. So this function value is to be 0.030, and approximate error, if we find out the difference of these two, 0.59375, 0.59375, 0.59375 minus of new approximation is 0.578125, divided by new approximation is 0.578125 into 100. So approximate error, which is going to be, earlier it was 5.26, it will be 2.7%. Approximate error is 2.7%. Now true error we want to find out. Approximate value is this one. The revised approximation is 578.125. True error is equal to 0.56. Revised approximation 0.578125 minus of 0.567382812 divided by 2. Function value is 0.567382812 into 100. So this gives us true value of function as, true error as 1.89%. So here we can write it as 1.89% is true error. Now this is positive. Positive is going to replace positive, so therefore 0.578125, so this value comes here, and 0.030, which is positive. Now this negative 0.5625, which is minus 0.012, which is negative. Average of these two we take here 0.5625, 0.578125. average will be 0.503125. So if we substitute this value in this function x e to the power of x minus 1, then we get this as 0.008. And approximate error, if we want to find out, so this previous approximation minus new approximation, approximate error is equal to old approximation is 0.578125 minus the revised approximation is 0.5703125 divided by 0.57032125 into 100, and this approximate error works out as 1.36%. 1.36%. 1.36%. And then we find out true error. True error is equal to, so true value of function we know 0.56, so approximate value, revised approximate value is 0.57, so 0.57032125 minus of true value is 0.567382812 divided by true value, that is 0.5673. 82812 into 100. This gives us approximate error, true error as 0.516, which is still greater than 0.5. So here this is 0.516. Okay. Now this is positive. New positive replaces old positive, or previous positive function is replaced by revised positive function value, that is nothing but 0.5703125, and this is 0.008 positive, and this is continued as 0.5625, and negative is 0.012, which is negative. So taking average of this and this, 0.5625 and 0.570325, we get the revised approximation as 0.56640.625. Now substituting this in this function x e to the power of x minus 1, then we get this as minus 0.002, which is negative. Now taking approximate error, so this is old and this is revised. Approximate error is equal to 0.570325 minus of 0.56640625 whole divided by a revised approximation is 0.566400625 into 100. So on simplification, approximate error is going to be 0.68. Approximate error is 0.68. Now we find out true error. So true error, so true value we take as 0.567382812 minus of revised approximation is 0.5664025 divided by true value, that is 0.567382812 into 100. Now this true error is going to be 0.17%, so which is less than 0.5. So 0.17% is the true error. 0.17 is the true error. So therefore we can write as the answer or root of the function as the root of function f of x is equal to x e to the power of x minus 1 is 0.56640.625 with approximate error as 0.68% and true error as 0.17%, which is less than 0.5, which is given in the problem. So we can see here what is given in this problem. So this is the function, root lies between this, and the true error must be below 0.5
and true value of this, or true root of this function, is given here, which is 0.567382812. So now here what we have obtained as, this is the root, but true value is given as 0.567382812. So this is true value, and this is approximate value which we have obtained using bisection method. And this answer, or this root of equation which we have obtained, is having error of 0.17%, which is less than 0.5%. So this is the stopping criteria. We can call this as a stopping criteria. 0.5% must be the true error, less than 0.5%. There we have to stop this iteration. Where to stop? So for how many iterations we have to continue? Whenever this true error falls below 0.5%, there we have stopped. So stopping criteria will be different from problem to problem. Sometimes stopping criteria may be generally given as 0.5. At that time both errors should be below 0.5%. If the stopping criteria is given for true error, then we have to stop here. If it is given for approximate error, then we have to stop here. So we have to look at this. So this is how we have solved two numericals on bisection method. So in next class we will be looking at Newton-Raphson method. So we stop here.